Hi everyone, welcome to the class. My name is Wangil Singh and today we are tackling pair of linear equations in two variables for CBSE Class 10. Whether you are taking basic or standard maths, this session is designed as your ultimate last minute revision. I have carefully selected a compact set of questions to ensure we cover this chapter efficiently. And by the way, this is not a theory class. I'm assuming you already know the basics. So we will be diving straight into problem solving, but I will be explaining you the basics, the concepts, and the exact way to write your answers so that you score full marks. So without delay, grab a pen and notebook and let's get started. Okay, this is our first question and you just need to solve this pair of linear equations and find the value of x and y. So let's get started. So since the uh, coefficients here in these equations are in decimal, so I would like to convert them into um, rational numbers. So I simply multiply. I will multiply by 10 to both the equations. So if I multiply this by 10, so this equation is going to be 2x plus 3y equals to 13. Similarly, if I multiply this by 10, my equation is going to be 4x plus 5y equals to 23. Now this looks much familiar and it's quite easy like mentally for us, because whenever we see numbers in decimal it confuses us. Although it's not that difficult, but still I would suggest you to convert this way only. So now what do we do? We equate one of the variables, means we'll have to make equal either x or y. Here you see I'm going with equation 1. I will multiply this equation by 2. If I multiply this by 2, then I will get 4x plus 3y. So now after multiplying this equation by 2, I can see that the x variable in both the equations become equal. Now I can solve them. By the way, I haven't mentioned, I'm solving the pair of linear equations by elimination method. So when I solve by elimination method, I need to make one of the variables equal. That's what I'm doing. So I have made it equal. So next what I will do is I will keep this right below this equation. Next what do we do? Next mm, we keep the variable which is equal, we make them of different signs. So here both of them are positive, so one has to be negative. So what do we do is we multiply this entire equation by -1. If I multiply by -1, then this then just the sign changes. Like this plus 4x it will become minus 4x. This is going to be minus 5y, and this will be minus 23. Next, what do we do? We add them. So if you add 4x minus this, it's going to be 0, which we won't write. So if you add these two, 6y minus 5y, if you add them, answer is y. If you add them, answer is 26 minus 23 is 3. So we got the value of y. Now substitute this value in this equation. So answer is 4 into x plus 5 Instead of y, I will write 3. So, so we got the values of x and y. X is 2 and y is 3. Okay, now if you want to know whether your solution is correct or not, what you can do is what it's I would rather suggest you to always check your answers by substituting these values in one of the equations. If left hand side equals to right hand side, then it's correct. For example, let's put the value of x and y in this equation. So this is going to be 4 into 2 is 8. This you can do it in your rough. 4 into 2 is 8 plus 5 into 3 is 15. So 8 plus 15 is 23. So our answer is correct. So that's how we check and move on. Now we will deal with another question. So here comes our second question. Similar to first one, we will be solving them by either substitution or elimination method. I usually go for elimination, so this one also I'm going to solve by elimination method. So uh, let's start it. So first, I also suggest you when you copy the question, when you start solving, I suggest you to write the two pair of linear equations like adjacent to each other. Why? Which I will show it to you. Let's just follow it. Since the LCM of both the denominators is 2, here LCM is 1. Sorry, not 1, it's 3. LCM of 1 and 3 is 3. This is going to be 3x. So I am solving both the equations simultaneously. So even you can also do it, and it's for me. I feel that when I write both the equations adjacent to each other, it's easy for me to compare. So this 2 will go on the right hand side and it will multiply with -1, so it's going to be -2, while here 3 is going to go on the right hand side and it's going to be 9. 3 into 3 is 9. So this is our, let's say, equation 1 and this is equation 2. Similarly, just like the previous one, we will solve the two equations by elimination method. I will write this equation right below this equation. What do? Our one of the variables must be equal. So in this case, y is already equal, and their signs must be opposite, right? One is positive, another is negative. So nothing to do. What will we just need to add them? So if we add x plus 3x, it's going to be 4x. Y plus minus y, so this is going to get cancelled, equals to -2 plus 9. So answer is 7. So x equals to 7 by 4. Now, so I'm substituting x equals to 7 by 4 in equation 1, we'll get so finding the LCM. taking the LCM, sorry. So finally our answer is minus 15 upon 4. So value of x is 7 by 4 and value of y is minus 15 by 4. So if you when you get the answer, sometimes we are also not sure whether the values which we get or is correct or not. What we can do is we can simply substitute the values in the equation in the given equations and check whether left hand side or is equal to right hand side or not. For example, you may put x equals to 7 by 4, and in place of y you can put y equals to minus 15 by 4 and add them. The sum must be minus 2. If that is true, then your answer is correct. By the way, this is the correct solution, so I'm not checking it. You can do so during your exam. Okay, we'll move on to another question. All right, this is question number 3. We have a pair of linear equations in two variables s and t. So one is s minus t equals to 3, another is s by t plus t by 2 equals to 6. So we'll have to solve them and find the values of s and t. So I'm planning to solve these uh, equations by substitution method. So let's go for it. So this one I'm going to do s is I'm going to keep as this s equals to 3 plus t, and here let's find the LCM. 6. I hope you know how these follows. These are very simple equations. This 6 will go on your right hand side and multiply with this 6 and it becomes 36, right? Let's say this is equation 1 and this is equation 2. So we'll substitute the value of s from 1 to in this equation. So we'll get from equation 1. I hope you understood. So what happens is, after we substituted the value of s as 3 plus t in this equation, now this equation becomes a linear equation in one variable, that is only t. Now this is very easy to solve, right? So this becomes so t equals to 6, right? So let's substitute the value of t over here. You can say this equation 3. Okay, so I can write this as s equals to 3 plus 6. How? From equation 3. All right. Therefore, S equals to 9. Hence, the values of S and T are S equals to 9 and T equals to 6. You may verify by substituting those values in the main equation. So 9 minus 6 equals to 3. So it's correct. You can try it here also. It's going to come 6. So let's move on to another question. Okay, now let's look at this question. It says in figure ABCD is a rectangle. Find the values of x and y. So as you can see, the figure in a rectangle, the opposite sides are equal. Means this side is equal to this and this side is equal to this. So I can write x plus y equals to 30 while x minus y equals to 14. Let's say these two are breadth of the rectangle and these two are length of the rectangle. And so what do we get? Equating them, we get two linear equations in a pair of linear equations in two variables. So we can solve them. So in order to solve by elimination method, the variables must be equal and their signs must be opposite. So it's there. Both the variables are equal, but when we look at y, the signs are opposite. So we simply add them. When we add them, the answer is x plus x is 2x, y plus minus y, this gets cancelled, and 30 plus 14 is 44. So x equals to, when we divide 44 by 2, it is 22. So similarly, we'll find y by substituting the value of x in any of the equations. Let's take this equation. X plus y equals to 30. So we have y equals to 8 and x equals to 22. So if it's correct, you can check in the figure here. 22 plus 8 is 30. So 30 is equals to 30. 22 minus 8 is 14. So our answer is correct. And this is how we solve the question. Sometimes let's say an equation similar to this is given and they might say find the value of m if y equals to mx plus c. Find the value of this m. After solving the equation, find the value of m if y equals to mx plus c. So what do we do here is we first solve the equations and substitute the value of y and x in this equation. For example, y is 8 equals to m, we don't know. Let's say instead of c there was another number, a number, let's say 3. So m times x is 22 plus 3. So you solve it and the answer is given by 8 minus 3 is 5 upon 22 equals to. This is also a possibility. I mean, this kind of question can also come in the exam where a pair of linear equations is given. So after solving them, after finding the value of x and y, we'll have to put that value into something else and find an unknown like m here. So I hope you understood this question. So we'll do another one. Okay, now look at this question. We see a pair of linear equations, but the coefficients are too large 2025x plus 2026y equals to 1, and 2026x plus 2025y equals to minus 1, then x minus y equals to how much? So when we see questions like this, you you observe the coefficients of x and y. A pattern follows. Like usually what comes to our head is like we solve the pair of linear equations by elimination method or by substitution method, find the value of x and y individually and then subtract them and put it here. So that is also correct, but that will take a lot of time. So what do we do here is we we solve it in this manner. So I can do this, right? Now if I directly add them, this is going to be this is going to be how much? 4051, which I don't require. I would rather change the sign of the this lower equation. I will multiply this equation by minus 1. If I multiply this by minus 1, then this entire equation becomes, this one will become negative, this is going to be negative, and this is going to be positive. So now let's add them. So if we add them, the answer is 2025x minus 2026x. This minus x. So if you add them, it is plus y equals to 1 plus 1, 2. So the question is to find x minus y, but we have found minus x plus y. So what I will do is I will again multiply this equation by minus 1, which I can do because even if I multiply with any other number, the equation is always going to remain balanced. So if I multiply this by minus 1, so it's going to be plus x minus y equals to minus 2. So this is the solution. All right. So whenever you see equations of this type, it might be some other numbers, but a pattern is there. 2025 same, you can see the numbers, so you can solve the problem by this method. All right. So we'll move on to another topic or another question. All right, before we move on to another question, I think I will be needing some extra minutes just to explain what the upcoming questions are about. And in fact, all the questions from now on that we will be dealing is based on this idea. So let's bear some time for the topic that I'm going to discuss. Okay, that is consistent, inconsistent, consistent and inconsistent pair of linear equations. So what does this mean? A pair of linear equations are consistent or inconsistent. Okay, when we have a pair of linear equations, let's say, for example, what does linear equation in two variables represent? First of all, it represents a straight line, right? If we draw a graph of this linear equation in two variables, if this is a graph which is this, let's say this are x-axis and this is y-axis and this is the origin, and let's say for example this line, this equation represents a straight line like this. What about this another equation? This one will also represent a straight line, but will it be, what are the possibilities of this straight line when we draw it in this graph? It can either be parallel to this line, right? It can either be parallel like this, means they will never meet, or another possibility is like, let's say this is the first line, the second line can be, the second line can intersect the first line at a point. This, let's say case 1, case 2. While the third form is that, what is the possibility? Is that the two lines can be coincident. That means if this is the first line, let's say, the second line can, if this is the first line, the second line can also lie right on top of that first line. So this is the case of coincident lines. This is intersecting lines. These are parallel lines. So when we draw a pair of linear equations on a graph, these three possibilities, these three things can happen. Let's say either they can be, either they'll be parallel or coincident or intersecting. But the problem is, without drawing, without even plotting the points or connecting the points and looking at the lines, how can we say the lines are parallel or intersecting or coincident? So that's what we are going to deal about. And another thing is that consistent and inconsistent. When we say consistent and inconsistent pair of linear equations, we can also say, um, we should also think that, no, in fact, know that consistent pair of linear equation means it has solution, or solutions. Right? While inconsistent pair of linear equation means it does not have. It doesn't have solution. It doesn't have a solution. How? Has solution means when you solve them, you will get particular value of x and y. While the ones which does not have solution, you don't get that value of x and y. But if you look at it in the graph, it shows that the one which is intersecting, the line which is intersecting, it has a solution and it has only one solution, and that one solution is the point of intersection. Let's say this is x comma y. So this is the solution of the pair of linear equations intersecting at a point. So it has only one solution, which we say unique solution. This has, since the two lines are on top of each other, so there are not just one point, there are infinite points um, coinciding with the two lines, with both the lines. So we have infinite solution. Infinite solutions. Since there are so many, x, let's say x1, y1, similarly x2, y2, like that, there are many other points which lie on both the lines. So that's why we say that this pair of linear equations has infinite solutions. While when we look at parallel lines, they are not meeting anywhere. So this pair of linear equations, or this line, this pair of lines doesn't have a solution. no solution. So consistent pairs are either intersecting or coincident, while inconsistent pair is only one which is parallel. Inconsistent means it does not have a solution. Consistent means it has a solution. Either it will have only one solution. When we have one solution, the lines are intersecting. It has a it has one solution, and that solution we call it a unique solution. When it has infinite solutions, the lines are coincident. So with this, I hope you understood. We'll move on to the problems ahead. All right, this is the question. So it says find out whether the pair of linear equations is consistent or inconsistent. Okay. So that means whether they have a solution or they don't have a solution. And how do we do it? There's a little rule which I forgot to explain. Now I will show it while solving this one. So first we will write these equations in the form this one a1 x. So both of these equations must be written in this form. Okay. So equation 1 can be written as if I bring this on your left hand side, it's going to be okay. Now compare equation 1 with this and equation 2 with this equation. Okay. So from equation 1, a1 is how much? It's 5. b1 is minus 3 and c1 is your minus 11. While from equation 2, a2 is minus 10, b2 is 6 and c2 is 22. After finding a1, b1, c1, a2, b2 and c2, what do we do is we'll calculate the ratio. The ratio is this. Calculate a1 upon a2. So now how much is this? As we can see, a1 upon a2, b1 upon b2 and c1 upon c2, all of the three ratios are equal to minus half. So we can say that uh, here so when this happens, when the three ratios such that a1 upon a2 equals to b1 upon b2 equals to c1 upon c2, then when this happens, we say the pair is consistent. So this is your answer. This is consistent. Like if you want to know the picture it forms on the graph, then although it's not required here, but this is consistent while it's coincident. Okay, the lines are coincident means if this is a graph, the lines should be something like this. If this is line 1, another line is also lying on top of this. L2 also lies on top of L1. So this is a pair of coincident lines. So it has infinite solutions, like the pair is consistent. That's it. Now let's move on to another question. Alright, this is our second question on the pair of linear equations and whether they are consistent or inconsistent. Um, we'll have to convert these two equations to this form. So equation 1 can be written as, and this one can be written as, right? So from here, my A1 is 4 by 3 and C1 is how much? Comparing this with this, it is minus 8. So now again we will calculate the ratio. Now A1 is 4 by 3 upon 2. So which is 3 into 2. So dividing by 4, it's 4 2s and 4 3s. So here also we see that, so here also we see that the three ratios are equal or they are in proportion. Hence, um, hence the pair is consistent. And if you plot the lines on a graph, you will see that the lines are coincident. So there are other questions where the lines are consistent, but mm, they are not coincident. They are intersecting at one point, or they are inconsistent means they are parallel. So let me tell you in brief, like when this means consistent, or consistent means it has a pair, it is the lines are coincident. While if I say if this was not equal to C1 upon C2, suppose, okay, then this means the pair of lines are parallel. If the ratio happens to be like this, then we say the lines are parallel means it is inconsistent in that case. Okay. And another is like if A1 upon A2 is not equal to this, forget about this one. Okay. We won't consider this at all in that case. If this thing happens, then the lines intersect at a point. Means it is consistent, but the lines are intersecting. It has only one solution. So I hope you understood what does consistent and inconsistent means. Consistent means it has a solution. Inconsistent means it does not have a solution. So when, and also I hope you understood by the proof, by the ratio which needs to be shown whether it's consistent or inconsistent. This means they are consistent. Well, let's move on to another question we have. Okay, now we will solve this question. It says find the value of k for which the system of equations this and this is inconsistent. In the bracket it's written has no solution. Inconsistent and has no solution means the same. So that's why sometimes instead of is inconsistent, you can see has no solution, or instead of has no solution, you may see this in the question. But remember, both means the same. All right, we will find the value of k. So let us rewrite the equation in the form ax plus by plus c equals to 0. So we will write both the equations in this form. In this one. All right. Now, now we will find a1 upon a2. The coefficient of x is, it's nobody means it's 1. So a1 is 1 and a2 is 3. Similarly, b1 upon b2 is 2 upon k, and c1 upon c2 is minus 5 upon 15, which is minus 1 by 3, because 5 ones are 5 threes are. Okay. Find the value of k for which the system of equations this and this is inconsistent or has no solution. When does it happen? It happens when the ratio is like this. You may say this is given. Okay. Means this is inconsistent. Inconsistent means a1 upon a2 is equal to b1 upon b2, which is not equal to c1 upon c2. Since these two are equal, we will equate them and find the value of this unknown k. So a1 upon a2 is 1 by 3 and b1 upon b2 is 2 upon k. So after cross multiplying, the value of k is 6. Just one extra information, this is inconsistent. When do we see a pair of linear equations inconsistent? When it does not have a solution. That means in the graph when they are parallel, when the two lines are parallel. So the value of k is 6. I hope you understood. So we will move on to another question. Okay, this is another question similar to the previous one. Find the value of k for which the system of equations 2x plus 3y equals to 7 and k plus 2 times x plus 3 into 1 minus k times y equals to k 5k plus 1 have infinite solutions. So for this case also we'll have to find the value of k where the pair of linear equations have infinite solutions. So how do we do it? First, we'll write these two equations in this form. So all right. Let's say this is equation 1, this is equation 2. So from here, from 1, okay, from 1 and 2, let's find a1 upon a2. So a1 is 2, a2 is your the coefficient of x, that is k plus 2. So b1 is 3, b2 is coefficient of y, the entire value, 3 times 1 minus k, and this 3 gets cancelled, and c2 is minus times, all right. This is minus, by the way. So they have said that the value of k, to find the value of k for which the system of equations this and this have infinite solutions. So for infinite solution, so this is the proportion that you must show in order to prove that the two lines are infinite. Okay, now let's put it here. So we see the three ratios are equal. We'll take out 2 and find the value of k. Like for example, if you see x equals to y equals to z, then we can say x equals to z or y equals to z, something like that. Okay, not something like that, similar to this one. We will pick, I shall bring this and this. You may equate this with this or this with this, still you'll get the same answer. Since I don't have a space here, I'm writing it here. Cross multiplying will get, So when we divide 12 by 3, the answer is 4. So k's value is 4. This is the answer. I hope you understood how it's done. Okay. Now we will go with another question. It says the pair of linear equations this and this represents two lines which are intersecting, coincident or parallel. So which is the correct answer? Either they are intersecting, coincident or parallel. We will check it. Okay. Mm. So what do we do? First we write the two equations in this form: ax plus by plus c equals to 0. So this one can be written as 2x minus 5y minus 6 equals to 0. And from here, can write as 6x minus 15y minus 18 equals to 0. So let's check the ratio of the coefficients, that is a1 upon a2. So this is 2 by 6 is 1 by 3. So minus minus gets cancelled. 5 threes are, so it is 1 by 3. Similarly, so we see that a1 upon a2 equals to, therefore the lines are coincident. So usually you see this type of questions as multiple choice questions, and it offers only 1 mark. And for this kind of questions, uh, you don't need to show the working. So what you can do is, you can get your answer in a very little amount of time, just by comparing the coefficients from the question itself. Like, first you write the questions, means first you write the equations in this format, and here only you can check, like, this is a1 a2 b1 b2 c1 c2. So here you can see it is 1 by 3. So this is also going to be 1 by 3, and here it's also 1 by 3. So it's going to be so this is equal to this. So you can say that the lines are coincident. So you don't have to write all these things. So let's move on to another question. Okay, now we will solve this question. It says, given the linear equation 2x minus 3y plus 8 equals to 0, write another linear equation in two variables such that the geometrical representation of the pair so formed is parallel lines, coincident lines, and intersecting lines. In fact, we'll have to write three equations, three different equations. One equation is such that that equation with this one, that equation, the three equations represents three straight lines. But the problem here is that straight line with this must be parallel in the first case. The another equation of that straight line must be coincident with this, and the third one must be intersecting with this line. So how do we do it? One. Let's find the parallel lines. So given one equation is this, So from here, I can say A1 equals to 2, B1 equals to minus 3, and C1 equals to 8. So we have to find another pair such that that equation with this one becomes parallel. And remember, A1, B1 and C1 are fixed. So this is the condition for two straight lines to be parallel. So since our A1, B1 and C1 are fixed, so we'll find A2, B2 and C2. Please write with this. Now, for instance, like for now, what we'll do is just write the multiple of these values A1, B1 and C. I mean, except one, you can write a multiple of any number, any positive or negative number. So I'm choosing 2 for now. So multiple of 2 is, this becomes 4, this becomes 9, sorry 6, and this is your 16. So this is not the final answer, by the way, this is just checking. So what happens if we do this? That every ratio is equal to half. So this is 1 by 2, 1 by 2 and 1 by 2. But the condition says that the last ratio C1 upon C2 must not be, it should not be equal to this. So we can change this number by any other number so that it does not become equal to this. I will write it 7. So our equation becomes, therefore, the equation is, this is A2. Similarly, this is our B2 and this is C2. So this is the equation of the line which is parallel to this line. I hope you understood. So we will find two more for coincident and intersecting lines. So, okay, for coincident lines, the condition is this. I hope you know by now that the three ratios must be equal. So again, you will just multiply by 2 or 3. Okay. If I multiply by 2, it's going to be so here each ratio is equal to half, isn't it? This is half, this is also half, this is also half. So this implies that A1 upon A2 equals to B1 upon B2 equals to C1 upon C2. Therefore, my equation is four x minus 6y plus 16 equals to 0. So this is the equation of the straight line which is parallel to, which is coincident to this given line. Similarly, we'll find an equation which is intersecting to this line. Can we do so? Of course. So intersecting lines, the lines intersect when a1 upon a2 is not equal to b1 upon b2. So we have from this one a1 is 2 and b1 is minus 3. So you choose two numbers such that it's not equal to them. It's the ratios are not equal. So I can write 1 and 4. So this is like basically 2 is equal to not equal to minus 3 by 4. Or similarly, what we did before, you can write as this was the case. You just write a multiple of 2 is 4, multiple of minus 3 is when you multiply this by 2, it's minus 6. But if you do this, it's going to be half, right? Both of them are going to be half. But I will make a simple change. Let's make this positive. Now it's not equal. So this is half is not equal to minus half. This is something like half is not equal to minus half. Therefore, the equation is, this is the coefficient a2 4x, this is the coefficient plus 6 plus 6. And what about c? C you can choose any number. Okay, so I will choose I can choose 8 also. Let's choose 5. So this is the equation of the line which is intersecting with our given line. So I hope you understood how to find the um, lines which are parallel, coincident and intersecting with the given lines. You just multiply the entire equation by, I would suggest you to multiply by 2 or 3, a very simple number, and then you just balance them with the necessary adjustments like changing signs or taking care of that c value, which you can put it on your own. Okay, now here we come to the end of today's class. Thank you for staying with me till the end. I hope this video helped you understand the questions more clearly. In the next video, we will continue with the remaining questions and work through word problems and graphical solutions on pair of linear equations in two variables. Till then, keep studying and keep practicing.